Okay, so I looked at the homework that was due last night, and numbers 3 and 4 had a little bit lower success. So let's just do one of those. They're the same type of problem. So let's look at number 4. I'll just work through that one. Unfortunately, these windows where the homework sets are, I can't make those the text bigger, so I'll have to write it out. So it says data on the number of pups born in a lifetime by each of 16 great white shark females are provided. Okay, so they had 16 sharks and how many babies they had. So I'll rewrite the data here in increasing order. So it looks like there was a 0, a 1, a 2, put a cross off here. Help me if I miss one. There's 5 is next, 2 5s. 2 6s. 2 7s and 3 8s. One, 2, 3, 4 8s. Nine, 10, 13. Is that 16? 1, 2, 3, 4, 5, 6, 7, 8, 9, 12, 13, 14. Good. Okay, got them all. Okay, so here's our data set. I put it in order. So we want to get the quartiles. So we know the second quartile is the median, right? So since there's 16, it's going to be the average of the 8th and 9th data point. Right? So 1, 2, 3, 4, 5, 6, 7, 8. So it looks to me like the median is going to be 7. It's going to be the average of the 2 7ths, right? And then, so we put that in here. And then the first quartile is the median of the lower half of the data set. So that's going to be between 4 and 5, since there's 8 data values. 1, 2, 3, 4. Again, there's 2 5s there, so the first quartile is going to be 5, looks like. And then the third quartile, 1, 2, 3, so 7, 2, 3, 4. Again, 2 8s would be the middle of the upper half of the data. So the average of those is 8. All right, let's see how we did. Huh, what did I do wrong? 7 is not right. 1, 2, 3, 4, 5, 6, 7, 8, 9. What am I doing wrong? Nice and loud. Oh, okay, I don't feel as bad. There we go. Okay. All right, interpret the quartiles. The quartiles suggest that all the sharks had between 5 and 8 pups. No, right? Just that's the inner quartile range, between 5 and 8 pups. The quartile suggests that 33% of the sharks had less than 5 pups. 33%. Now we know that these quartiles break it up into 25, right? Not 33%, but quarters, right? So it's not 33%. Quartile suggests the average of the pups was 7. Quartiles have nothing to do with average, right? It's all based on medians, not mean. So hopefully it's this last one. 25% had less than 5, 25% between 5 and 7, 25% between 7 and 8. That's quartiles, right? 25%, quarters, right? Quartiles, quarters of the data. Okay, determine the inner quartile range. You know, the inner quartile range is that range from quartile 1 to quartile 3, the middle 50%. So it's going to be 8 minus 5. It's going to be 3. Right? So it's going to be the quartile 3 minus quartile 1. Okay? Interpret the IQR. The approximate difference between each quartile is 3. No, this has to do with the middle 50% of the data. The average of the first quartile, no, it's not about average. The data spans roughly 3 pups. No. The number of pups produced in the middle 50% has a span of 3. There we go. The middle 50%. That's what the inner quartile range is. 5-number summary. Okay, so the 5-number summary, remember that the first and last might be the max and the min, or they might be, what, 1.5 of the inner quartile range away from that quartile. So we have to do 1.5. So the middle, so this is the easy part. This is quartile 1, and this is quartile 2, the median, and this is quartile 3. But these, the outer numbers are, could be, like that lower number could be the min, or the min could be an outlier, so it's not going to be that number. And similarly, the upper number could be the max, or it could be an outlier, so that wouldn't be that. So we need to check this number 1.5 times the inner quartile range, in this case 3, so that's 4.5. And then we're going to go 5 minus 4.5. So you take quartile 1, and that is 0.5, which means that this is an outlier, or potential outlier, because it's not. So now we're not going to use 0, we're going to use this number 0.5. And then for the max, we're going to go 8 plus 4.5, which will be 12.5. Am I doing it right? So we take quartile 3, and we're going to add 4.5, and that's 12.5. And again, 13 does not, it falls outside of this. So we're not going to use the max, we're going to use 12.5. Okay, they're saying it's, okay, so am I mixing this up with the diagram? The diagram, it's the diagram that does that. All right, so anyway, so we've got that under our belt. So the 5-number summary is the max and the min, sorry. I made it too hard. So we want 0 and 13. And it's all that stuff I was talking about is that box and whiskers plot. Okay, but the 5-number summary, okay, is the max, is the min, Q1, Q2, Q3, max, okay? My bad there. Let's try it again. Okay, so hopefully that work is going to, or interpret the 5-number summary. The data is approximately uniform. No. Is that right? 0 to 5, yeah. Each quarter is about the same. No, that's not right. Each quarter has about the same amount of variation. Quarter 1. No, these middle 2 quarters have less variation. That's not right. The middle 50% has the greatest variation of the data set. The first and fourth quarters have the least variation. 5, 3, that's wrong. The middle 50% has the lowest variation in the data set. 3. So this is a variation 5, variation 3, variation 5. First, yeah, that looks right to me. So it's saying, so the middle is 3. We already got the interquartile range. The lower 25% has a range of 5. The upper has a range of 5. The variation steadily increases from first to fourth. No. The variation steadily decreases first to fourth. No. It goes 5, 3, 5. Okay, almost the end. Potential outliers. Okay, so we already did that. So I did the interquartile range times 1.5, and we found that that's 0. The max and the min were potential outliers because they were outside of that 1.5 IQR number. So I think 0 and 13. Got it? Okay. Almost done. All right, and so then we did it and we found that it was 0.5. Let's write it down again. 0.5. And then 5, 7, 8. 12.5. So how come none of those choices look right? Well, they're showing the outliers here, so it's going to be one of these two. What did I do wrong? They both have the 5 to 8. This one looks like 1, 12.5. Did I do something wrong with this? Thought it was 1.5 times the interquartile range, which is 4.5. And then you're going to add that to Q3, which is 8, 12.5. I think it should look like this. It should come out to here like this. Why? Oh, I see. Okay, so right, that just tells you that it's an outlier, but then you go to the next data point. Yeah, so when you make the diagram. Okay, so it's going to go out to 10 and down to 1. So which one goes out to 10 and 1? This one. Okay. Any questions on that? Is there still more? Another one. Here, the 2 potential outlying observations fall slightly outside the limits. The other observations vary from 1 to 10 pups. The majority of the sharks have between 5 and 8 pups. That's our conclusion. Okay, so what did your teacher learn? Your teacher learned that the 5-number summary is uses the max and the min, right? Uses the max and the min. And then when you build a box plot, you look for the potential outliers by that 1.5 times IQF rule. You add and subtract that to your Q1 and Q3. And then when you draw the box plot, you're going to draw the outliers, but then this is going to be an actual, so the least data point that's not an outlier, and the greatest data point that's not an outlier. Any questions on that? So that had the most partial credit. All the rest of them were lots of hundreds, 100% for all of you. Questions before we move on? Okay, so we're going to go on to chapter 5. Which is probability. Fun and easy stuff. So you all know probability already. Okay? Suppose you roll a die. What's the probability that you get a 4? What's the probability that you get a 4? 1/6. So let's talk about, so 1/6. What does the 6 mean? What does the 6 mean? There are 6 options, she said. Yeah, there's 6 possible outcomes. 6 possible outcomes. And what's the 1 mean? Just the 1. What does the 1 mean? Is it rolling a 1? Is that what that is? 1? What's that? 1 is not a chance. Just 1. What does 1 mean? 1/6 is the chance of getting 4. What is the 1? What's that? I'm sorry, I didn't understand. Yeah, so out of the 6 possibilities, how many of those 6 possibilities are 4? That's what we're saying. So how many of those are 4? One of them. Just this, right? It's saying this possibility, or not possibility. Yeah, this outcome. There's just one way to get, so this is a number of ways to get desired outcome. The chance of it is 1/6, but the numerator is the number of possible ways out of the 6. So you've got these 6 possibilities. Out of those 6 possibilities, how many of them are the desired thing, the rolling a 4? Well, just one of them. Just getting 4, right? 4. So this is the basic construct of a probability. The number of possible outcomes in the denominator and the number of ways to get the desired outcome in the numerator. Okay? So I've got some practice for you here. So a pip is a dot. All right? So right there, turn on red. That is a pip. So the 6 side, the side with 6 has 6 pips on it. That's what a pip is. It's a dot. Okay? So now you do these. Okay? Okay, so we're going to be doing some group work today, so why don't you just get next to someone that you can work with. Because I'm going to give you some more group work. Stand up and sit next to somebody else. Work together. Okay, I'm going to hand back quizzes. So here's the deal with this. Just look it over later. Okay, so keep your attention on whatever task we have going on at hand. And just look over the scores and your grading later. I know you want to do that immediately, but try to resist that temptation. Actually, on the next activity, I'll do that. But take a minute to do these. Okay, what's the probability of even? What's the probability of even? 3, he wants 3/6. Agree? Six possible outcomes, 3 of them are even. Right? Okay, exactly 2 corners have a pip. What do you think? He wants 2/6. Which ones? Which ones have a 2 and 3? So theirs would be 2 out of 6. Of the 6, these 2 have exactly 2 corners with a pip. Make sense? Exactly 2 corners. Exactly 2, right? Exactly 2 corners have a pip. And how many corners have a pip on number 4? 4. So exactly 2, not at least 2. Okay, greater than 1. Should be 5. You should get 5/6. Okay, less than 10. 6/6. Probability that you don't get a whole value. What is it? 0 out of 6. All of them are whole values. 1, 2, 3, 4, 5, 6. Okay. So now if we order these from least likely to most likely to occur, what was the least likely to occur? Not a whole value, 0 to 6. In fact, it's impossible, right? So 0 out of 6 is a probability of 0. That means impossible. Can you get any worse than that? Yet, students throughout the ages have tried to report probabilities as negative. But you can't get any worse than 0 you can't get worse than 0 probability. Because that means there's no, see, if this numerator is a subset of this, it's like how many of these are what you want. Well, you can't do worse than 0. You can't do worse than 0. It can't be negative. No negative probabilities. Okay? What's the most likely to occur? Less than 10. Because of the 6, how many of them qualify? All 6. Can you do any better? This is certain. So when you roll a dice, it's certain that you're going to get less than 10. Probability of 1, right? Probability of 1. Can you do any better than that? No. Yet, students throughout the ages have reported probabilities of 1.5, 2, 2.1, 3. Don't do that. The best you can get in probability is 1, and it means absolutely certain. You can't do any better than that. Okay? So all probabilities then span from 0 to 1. So I made a little scale here. So 0, this was our impossible. Okay? And then remember, no negative probabilities. Doesn't make sense. Zero is the worst you can do. You can't do any worse than 0 out of, in this case, 0 out of 6. And that's an impossible situation. It will never happen. Okay? And then, what was our 1 here? So this one is probability of 1, certain. It's a certain event. It will happen. It's going to happen, for sure. But remember, no probabilities. What? Greater than 1. You can't have probability 1.2. If you end up reporting a number like 1.2, 1.8, that means you're just cranking out numbers and you're not thinking, right? You got to think about what your answers mean. Probability of 1 is the biggest that probability can get. So what about probability of 0.5? We had one of those. Which was probability of 0.5? Right here. Rolling an even, right? Rolling an even. What does that mean? If something has probability of 0.5, that's special, right? Because it's halfway between 0 and 1. So what would that mean? How would you describe what a probability of 0.5 means? 50% chance? What's that? Half chance. But what does that mean? So what does a 50% chance or half chance mean? So what could happen? It could not happen, or it could happen. And how do those two compare? Yeah, so what you have is the equal likelihood that it does not happen as it would happen. So it's equally likely to happen as not to happen. I'll abbreviate that this way. Equally likely to occur or not. That's what a probability of 0.5 means. Okay, what else did we have along the way? So what was, after 0, what was the next most likely thing? Rolling a 4, right? So that's 1/6 is about 0.17. So that's about right here. 0.17. And then what was next? This one that I said, exactly 2 corners have a pip. That's what, 1/3 or 0.33. So what's happening as the probability increases? So when probability increases, like say rolling a 4 versus getting a 2 or a 3, what does a greater probability mean? Yeah, it's more likely, more likely. So we started impossible, and as we increase in probability, you're saying the event is a little more likely than the previous one, until we get up to what a half is equally likely to occur or not to occur. And then what's next? 5/6. That is 5/6 is about 0.83, 0.84 around there. So, more likely to occur or not to occur? More likely to occur, right? A lot more likely to occur than not to occur when you're up here above 0.5. All the way up to 1, where it then becomes an absolutely certain event. So it's a scale of likelihood. That's what probability is. Starting at 0 of impossible, all the way up to 1 of absolutely certain. As your probability increases, it's more and more and more likely to occur. Halfway, equally likely to occur or not. Okay, does that make sense for a general overview of probability? Okay, so why don't you guys practice some stuff here. Oh, so here's just it's the same thing we said before. It's a little more fancy. Probability of event is number of ways the event can occur, total number of possible outcomes. We already said that, okay? But this is the starting point for all probabilities. Okay, so now I'm going to let you go. Does everyone know what the first thing doesn't need an introduction, but does everyone know what a standard deck of cards consists of? Okay, so if you don't, then hopefully between you and your partner you can remember that. But there's 4 suits. There's spades, diamonds, clubs, and hearts. And then in each of those suits there's 13 cards. Ace, 2, 3, 9, 10, and then Jack, Queen, King. So there's 13 cards, ace through 10, then Jack, Queen, King. In spades, that same set in diamonds, that same set in clubs, and that same set in hearts. So that makes 52 total cards. Okay, not everyone is familiar with that, but you need to know that to answer number 2. Okay, so work through all these questions with your partner. Miguel. $13 out of 16. So which of those is most likely of those first 3? C. Highest probability, closest to 1. That one would be most likely green. Of these 3 events, green would be least likely. Okay, so what's an event that has a probability of 1? Yvonne, did you come up with one? What's that? A marble. You get a marble. Probability that when you pick a marble, you get a marble. Any color. Anybody have something else? That works, right? That's certain. Any other creative options here? Yeah. Okay, yeah, green, blue, or red. Yeah, you could have said probability. The event is that you get a green, blue, or red marble. That's fine too. Yeah. All right, probability of 0. What's that? Probability of a yellow marble. Yeah, pick it just another color, right? Probability that you get a die, a dice, right? You're not going to get that. So, but probably any other color that's not shown. Okay, probability is equally likely to occur as not to occur. Whitney, what's that? Probability. She wants probability of blue. Yeah, probability of blue. And so I didn't really mention this. This notation, capital P and then the event, means, like you saw on the previous slide, probability of blue. And so that would equal what, Whitney? 8/16. And that's our 1/2. 1/2 probability. Okay, let's do the deck. Probability that you get a club. Kayla, did you get that one? 13 out of 52. And that reduces to, what does that simplify to? What is 13 out of 52? 1/4. 1/4%. Or sorry, 25% chance. Okay? So notice, so the numbers are what? From 0 to 1. So we got, like this one, we just got 0.25. And then the previous one here, we got 0.5. This is kind of like something we've seen before, earlier in the course, like in the first week. Do you remember what it was? A number from 0 to 1, a decimal value from 0 to 1. Remember what that was? What was it? Remember? Relative frequencies, remember? So relative frequency was this like portion of all the data that was a certain situation, a certain event. So these are like twins. So the idea of relative frequency and probability are like almost one and the same. Why? Because the relative frequency of getting a club is 0.25. And that's what the probability of getting a club is. Okay? So remember that concept of relative frequency. It was like a percent or the portion of everything, which was 1, right? That is the focal event. And that is the same as probability. So these are they're like twins, relative frequency and probability. Okay, what's the probability of a red card? Kuzman. This one. What's that? 1 out of 52? A red card. Oh yeah, so I didn't really point that out. Yeah, so the diamonds and the hearts are all red, and the spades and the clubs are black. I forgot to say that. But yeah, 50%. Equally likely to occur as not to occur. It's a 50% or 0.5 probability. Probability of a face card. Ashlyn, did you get that one? 3 out of 13. And how did you get that? Okay, so in each suit, you've got 3 face cards, so that makes 12 total face cards, right? Out of the, what's that? Yeah, so the way you can know if it's a face card is if it has a face on it. So, but that's a common mistake that the ace is thrown in there with it. But the way you can remember it is literally, does it have a face on it? And only the jack, queen, and king has the face of a person on it. Okay, and so then you got four sets of jack, queen, king, which makes 12 cards out of the 52. And so then you said that that's just the same as 3 out of 13. So if you just look at one suit, it's 3 out of 13. And since all the suits are the same, 3 out of 13, it ends up being 3 out of 13, which is the same as 12 over 52. Okay, a black 7. Trevor, probability of a black 7. Can we do this together? So we just ask, how many black 7s are there in the deck? There's 2. There's a 7 of spades and 7 of clubs. So we'll do 2 over 52, which is also 1/26. Okay, 3 of hearts. Jason. 1 out of 52. Okay, a face card and a diamond. Felipe. Okay, so you're saying there's 3 face cards that are also diamonds. That's it, 3 out of 52. 350 seconds. Okay, less than 9 and greater than 4 and red. Rachel, did you get that one? And how'd you get 8? So she's counting 5, 6, 7, and 8 in terms of the numbers that apply here. And then it also has to be red. So you have those 5, 6, 7, 8 of hearts, 5, 6, 7, 8 of diamonds. So saying 8 out of 52. Is that? Miguel, what's up? Yes, there is. There is or. Did we have an or here? I didn't put an or in there. Yes.
Oh, sorry about that.
You see it?
Yeah.
Okay. Oh, we good on that one? 8 out of 52. But he brings up a good point. If you have or, so or means that it could be, like we had that one up there, blue or red. So it doesn't have to be both. So you could pick out a blue or a red one. So maybe a slightly harder one would be then a spade or a face card. All right, so what's the probability of a spade or a face card? So this is a little trickier. So first of all, if you pick a face card that is a spade, does that fall under this umbrella of a spade or a face card? So like the queen of spades. Yes or no? Is it a spade or a face card? Absolutely. Am I a math teacher or tall? Yes or no? Yes, I am, right? Just because I'm both doesn't then throw me out of the category, right? So absolutely, I'm a math teacher or tall. Okay, same thing here. So now we got to figure out how many cards are spades or face cards. How'd you get 38? How many spades? So tell me where you're getting that. 13 spades and 12 face cards. So that means there's 25 cards that fall under this category. Agree? What are you counting twice? Okay, so that should have felt, okay, that's not quite right, because this is too big. Because here you counted, in this 13, you counted the jack, queen, and king of spades. Yeah, so and then here you also counted the jack, queen, and king of spades. So we could correct it by doing what? Subtracting 3. And that's like 9, right? So it's like we got all the spades, so we don't want to recount the spades that are face cards. So we want the other 9 face cards. So this would be 22 out of 52, not 25. That's a little trickier. So when you have or, you have to watch out for double counting. Counting everything that's both a spade and also a face card twice. You don't want to do that. So how about this? Is this event, a spade or a face card, more likely to occur or less likely to occur? So is it more likely to occur or not? Yeah, so it's less likely to occur than to not occur. So not occurring is more, because 26 out of 52, or 50% probability, is exactly equally likely to occur. So this is a little bit less likely than an even chance. Okay, any questions on, this is just practicing the basic setup of the fractions, because it seemed to do pretty well in that. Okay, so here is, if you tossed 3 coins and just look at the overall results of specifically 3 coin tosses, this is what you get. There's 8 possible outcomes. All right, so this is called all possible outcomes is called the sample space. So the set of all possible outcomes in a situation, or what we call an experiment, is called the sample space. And so how many events do we have here in this sample space? If you flip a coin 3 times, how many possible outcomes are there? 8, right? So this sample space has 8 possible outcomes. Or you could say the size of the sample space is 8. The size of the sample space is 8. Okay, so answer these 4 questions. Work together. Okay, this Kelly right here, did you get part A? So what's the probability that exactly 2 of the 3 tosses come up heads? And how'd you get that? Okay, so yes or no? This one? Exactly 2 heads? So this one? This one? Okay, so she's looking at these three fit the criteria, so it's 3 out of 8. So 3/8. Okay? The last two tosses come up tails. What's that? Scott says 2/8. Which ones are those? Just say heads and tails. So, like tails, tails, heads, tails, heads, tails. Head, yeah, head, tails, tails, and tails, tails, tails. Okay, all three come up the same. Laura. What's that? 1/8. What do you guys think? 2/8, because all can be tails or all be heads. This first one and the last one. Second toss comes up heads. Yes or no, everybody? Yes? No? Yes? No? Yes? No? Yes? No? So really this just comes down to, all you care about this second toss. What's the probability that a toss is heads? 1/2, right? So we could sit here and count them all, and we get 4/8. But really, it doesn't, since it just has to do with the one flip, and you're saying what's the probability that the one flip is heads, you ought to get 1/2, right? You ought to get 50.5. And you do, even if you count it using the 8 possibilities. So you can think of this one two different ways. You can count the number of outcomes out of 8, or you can just say, well, it's just talking about one toss being heads, and we know that's a 50% chance. Right? Okay, so we can label events with letters, usually capital letters. Okay, so like we could say A is the event, so A equals the first flip is tails. And B equals all three are heads. And C is the third flip is heads. So what this does is then it's like shorthand now. I can come over here and I can, rather than, once I do that event, then I can combine events and not have to keep writing out those statements. So I can say, what's the probability of A? And what's the probability of not B? And what's the probability? That's the question I meant to ask. Sorry about that. So just add 2 more to your list. Okay. Let's see. I forgot your name right here. Tell me. Jessica, did you get probability of A? 4/8. Okay, and I forgot your name right here. Sorry. Danny. Probability of not B. What'd you get for that? 7 out of 8. What is 7 out of 8? Okay, how about probability of A and C? A and C. What'd you get? How'd you get 1 out of 4? Okay. Okay. Okay, you're using something different than what we learned. Okay, but let's see. Since those are independent, that works. Okay. Be careful. If A has some influence on C or C has influence on A, then you can't just multiply the separate probabilities. But since A doesn't affect C at all, the event that A occurs does not change this, then you can just do the straight multiplication. Just watch out. So did anybody use counting to do this, the way we've been doing it? Kayla. Okay. Okay. So these over here are the first flip of tails.
There are 2 that have the same probability from A and C. So you're counting them like 2 twice.
So there's the 4 that's right. There's 4 that have tails at the beginning, and then of those, we're looking for which ones?
I'm confusing myself.
No, you started off great. You said there's 4 that have tails to start with. That's A satisfied, right? But we also need C to be satisfied, and. So of those 4, we're looking for what?
For the ones with the heads.
So which ones of those? How many? The first 2, right?
Yeah, so there's only 2 out of 8.
2 out of 8. Those 2. Okay, now how about A or C? A or C. You're on the edge of your seat, Enos. And how'd you get that? Okay, so the first flip is tails. All these would be in the mix. So then you're saying which of these also have the first flip or the third flip as heads? The first 2. So this one doesn't apply, and this one doesn't apply, because first is heads, last is tails, first is heads, last is tails. All the other ones have at least the first one is heads, or the last one is heads, or the first one is tails. So 6 out of 8. And that's 0.75. Okay, any questions on that? So you see how this is convenient, right? So we can just write down what those events are once, and then we can use this notation, this capital P notation with the letters, and not have to write this out over and over again, right? You can just write these out once, and then you can construct all kinds of probabilities using the letters that stand for certain events. Okay, one more example. So here is the following table showing the number of female hospitalizations for cardiovascular disease by age group during 1 year. Not terribly uplifting, but that's what we got. So one of these caseworkers selected at random. What's the probability that the woman was, you got the different events, in her 50s, less than 50. So here, what you have to do here is you have to look at less than 50, then takes into account more than just one category. So you have to account for that. I think you can do it. Finish this, we'll be done. So, think about what it's asking, and think about how you're going to use the table to set up the probability of number of possible outcomes. So let's get that. Anyone have that yet? Does it say? As soon as you get it, shout it out for all of us. Or let's just call it N. Anybody else get that? You did? All right, let's just do the last two. Just do C and D. If we can do C and D, we can certainly do A and B. So between 40 and 69, or 70 years and older. So what would you do to get part C, probability between 40 and 69 years old? What would you do? Desmond?
Around 10,000
He wants to add these three together and divide by the total. What do you think? Is that what you're doing? Yeah, so you're going to include, so you need to count how many satisfy this event, right? How many satisfy this event? We're going to have to add up those three categories and then divide by the total. And then what about 70 years or older? You're going to add up the last two. So for part D, you're going to add up these two. These are all the people that satisfy that event of 70 years or older. You're going to add up those two and divide by the total. Okay, I will have your quiz, Wednesday's quiz, I'll have that posted sometime this morning. And the homework due Sunday night is already up and right, or it's going to open at 9. Okay? So